Hello, I'm Walker. Today I'm doing a serial dilution. The purpose of a serial dilution is to reduce the concentration of a solution through a series of dilutions. This allows for an accurate measurement of high concentration samples and helps determine the number of bacteria in a culture. The supplies needed for this lab include a stock solution. I am using blue food coloring, water, and 7 clear containers, as well as a pipette. I have already filled these 6 containers with 9 milliliters of water. First, I will get 1 milliliter of the stock solution and mix it with 9 milliliters of water, producing 10 milliliters of liquid and a 1 to 10 dilution, or 10 to the negative 1. Next, I'll take 1 milliliter of the 1 to 10 dilution and mix it with 9 milliliters of water to create a 1 to 100 dilution, or 10 to the negative 2. Then I'll take 1 milliliter of that solution and mix it with 9 milliliters of water, producing a 1 to 1,000 dilution, or 10 to negative 3. And then I would take 1 milliliter of that solution and mix it with 9 milliliters of water, producing a 1 to 10,000 dilution, or 10 to the negative 4. Then I'll take 1 milliliter of that solution and mix it with 9 milliliters of water, producing a 1 to 100,000 dilution, or 10 to the negative 5. And finally, I'll take 1 milliliter of this solution and mix it with 9 milliliters of water, producing a 1 to 1,000,000 dilution, or 10 to the negative 6. Now that I'm done, you can see that the solutions go from least dilute to the most dilute. Let's say we took 0.1 milliliter of fluid from our 1 to 10,000 dilution and made a plate with it, and then the plate produced 75 CFUs. So the math for this example, you take the number of plaques or colonies, you multiply it by the dilution factor, and divide by the volume plated. So it'd be 75 CFUs times 10,000 divided by 0.1 milliliters. And then the results, you'd get 7.5 million CFUs per milliliter. This answer in scientific notation would be 7.5 times 10 to the 6 CFUs per milliliter. For my Think Out Loud, the section that I chose is day 2 of the serial dilution procedure, which says count the total number of colonies on the replicate plates with between 30 and 300 colonies. Note, you should not count plates with less than 30 colonies or greater than 300. Determinations from plates with less than 30 or more than 300 CFU are statistically unreliable. If you do not have any plates within the statistical valid range, check with your instructor for alternatives. Interpret your results. Use the results of your colony counts to determine the concentration of bacteria in the sample. Report values in colony-forming units per milliliter to 2 significant figures in scientific notation. Write your results on the board and in your book. I think this means after incubating your plates, you count the individual colonies. And if there's over 300 colonies, it could be difficult to read and give an inaccurate result. And if there's less than 30 colonies, there's not enough growth and also could give it an inaccurate result, and they should not be counted. After counting the colonies, you should do an equation to determine the concentration of bacteria in the sample. And to do this, you take the number of plaques or colonies and you multiply it by the dilution factor, and then you divide by the volume plated in milliliters. And then your result should be in scientific notation with the units, colony forming units per milliliter. And that will give you the concentration of bacteria in the sample for each dilutions. And then you will write that down to keep a note of it for later.